This project is one that Coastal Studies Institute as a group responded to a call for proposals from the North Carolina Department of Transportation to do an assessment of the potential impacts of dredging and deposition of the dredge material in the area in and around the Rodanthe emergency channel. They're interested obviously in continuing to use that emergency channel, and doing so requires routine dredging. They're also potentially interested in increasing their use of the area and potentially expanding the width of the channel that goes across Pamlico Sound. So if they were to change the width of that channel, that would create more material. So the questions we were trying to answer were, where can they put this dredge material, and where can they put it to have the least negative ecological impact and the most positive ecological impact?
Once you dig up material off the bottom, once you create a channel, let's say it's 5 feet, you need it dug to 7 or 10 feet. Well, that creates a lot of material, a lot of volume of sediment. You have to put it someplace. And so these spoils are basically creating bars or sometimes even islands of dredge material, right? So you can basically pump it off the bottom, creating a channel, and it's pumped to a location, and that location becomes a dredge spoil. It can be subaqueous, below the surface of the water, or it can create an island if there's enough material. And you see these sort of all over from the past. We aren't creating as many dredge spoils today because there are a lot of rules and regulations about what you can do with this sediment. And so what we're trying to evaluate is what is the source of material and how quickly it's moving around. And so if we are going to dredge that channel again, can we simply just place that material and create a spoil offshore, or will that material simply just be moved around and refill in the channel that we just cut? We have an area along the backside of the Outer Banks that are eroding fairly quickly, some areas more so than others. And so it might be that we can take this dredge material and create protection of the shoreline, or maybe extending the shoreline. And we need to go out and we need to collect samples. We need to collect bottom samples to have a good idea of the types of sediments that we see on the bottom. If we want to understand and develop models to understand the dynamics of waves and currents, we need to have a really good understanding of the bathymetry, or how the depth changes, the topography of the subsurface. And so we go out with an instrument referred to as a single beam. It's kind of like a really good depth sounder. And we can essentially map the bottom to get a very good understanding, very high resolution understanding of what the bottom looks like. So the variations in the depth, which really tells us how waves and currents will influence the bottom. So we can use the data that we're collecting to better guide DOT for the best placement of their dredge material.
So we have several sections in this project. One of them is ecological. The reason that that's an important focus is that area has quite a bit of seagrass, and seagrass is noted for providing very large quantities and a very wide variety of ecosystem services. And by ecosystem services, we mean things that the natural environment does that are of value to people. So some of those services from seagrass can be sediment trapping, so they increase the clarity of water through trapping sediments. They are great habitat for juvenile fish. They also are an area that is an active zone for nutrient cycling. So in many places they remove a lot of nutrients if they're there in levels that are beyond that, which is healthy for the system. And processes like denitrification, which is a natural process that removes nitrogen, are often quite high in seagrass beds. So in the context of this project, if seagrass are going to be affected by the deposition of sediment that's dredged, we want to be sure that wherever the material is placed, we also have plans to create new habitats that will be good sources of this process denitrification. So if we're going to lose some capacity to denitrify, we want to be sure to restore it. And optimally, what we'd like to do is have even more denitrification capacity once we've completed the designs for the sediment deposition areas. We've also found that in all of the sampling, there's a lot of denitrification in the marshes. And that's good because as we design deposition areas and design habitat enhancement around the deposition areas, we can feel confident that the marshes that we put in, any constructed marshes, will contribute to nitrogen removal.
The work of the maritime archaeologists in this project pertained to assessing the seabed. Before we started research in the field, we did extensive historical research to see whether there were things like shipwrecks in the area, and around that we would design a remote sensing project. So we use two main tools. One is a side scan sonar, which allows us to insonify the seabed to see if there are objects sitting up above the sediments. And the other tool is the magnetometer, which allows us to look for disturbances in the Earth's magnetic field created by iron and steel objects predominantly. And that will tell us whether there is potentially objects or cultural material below the sediment. The results of the survey have shown that basically there is no important cultural material in the way of deepening or widening the channel at Rodanthe. And so from a significance point of view, it's fine to engage in dredging and depositing sediment within the area.
Projects like this are really important because there was a time when sediment was seen and dredge material was seen as a waste product. And as we have more people living at the coast and we have more people being exposed to storms, we have what appear to be rising water levels, it's really important to consider how these ecosystems, whether they're human affected or natural, are going to be able to keep up with these changes in the environment. And so as we look at a project like this that's going to be doing a fairly significant engineering action, we can then couple the end product of that engineering action, the available sediment, to what we know about the natural system and put that sediment in places where it'll either create new habitats or augment new habitats.